So regarding the JIPipe one, also everyone did very well. So a lot of way beyond 90% for many people. So congratulations with that done. You worked hard on solving that and set that together, and trying to resolve these issues. And it's hard. It was hard, and I admit, as I talked to some, it might be not possible without having this set up here. But this is the intention. I made it only so hard because we had this set up here. And so you're encouraged to actually sit together and then try to solve it. So fortunately, I found my solution to it, so I don't have to start completely from scratch for you. So let's go through the task. So unfortunately, I had to change some bit. Thanks for the information where I missed some parts. The 8 points for the first for the tasks remained, but the questions, one you got as bonus points because I forgot that the JIPipe node already solves it for you, and I never had to you didn't have to use this functionality. But I will go through each question one by one, and then each task, and then give also my notes what I noticed with your pipelines there. So let's open the one that I made for you, and you will in the end receive a whole directory with everything solved, basically. So don't worry. I just have to copy it. So I have here my task one solution. I have to check if it's consistent with each other. I hear many people are sick. You worked so hard. You got sick from that. This happens. Will continue to be happening in the future. So task one was converting the first channel into its JIPipe equivalent form, and I noticed that some chose to follow more the macro and some chose to follow the description, and it's completely fine. Sometimes the description is a bit inconsistent with the macro. Didn't matter. I just want to see the structure. So it's absolutely fine regardless. And you were also encouraged to play around with it. I just want to see the specific patterns in there that you don't forget this. So this is my solution that we also will receive as directory and will upload it after that here into this Google Drive. And as everyone did, let's focus here on the transmitted light first. And I chose here this 2:1 image as its first one. And basically, everyone did it correctly. Nothing much to say. So got it to the Hessian. I have to fix it. This is what also many had as well, the same issue as me now. That sometimes when you move these projects around, if you look inside these file lists, what's happening in there, in the parameters, is when you save them out, and they are next to the project, so as I shown you in the lecture, then JIPipe automatically converts it into a relative path. You see that here doesn't say anymore see something, because I saved this project once next to the data, and then it detected that this is the case, and it automatically edited the file list. This is so the projects better run automatically. You don't have to do the manual fixing afterwards. But anyway, at some point, the project is converted into using these custom directories, and then there you have better control also later on. To fix that one, I have to first check here my directory. What I always suggested then, when some people had the issue, is to drag it in again. But you can also just edit the path here manually. So here it was in a directory above it. that was called for students, and I am have to remove that, and then it will work again. So you can run the file list, because the file list causes it when it's wrong. That will cause the error, and then you can also click go to in this error panel and to jump to the node that caused the issue. So now it ran, and let's run it until find particles 2D with update intermediate caches. So you get here this defocused one in the beginning, and you were free to use either the CLIJ one or the custom extended depth of focus. The custom one has maybe a bit worse quality, doesn't matter, will work regardless in the end. Then a Hessian, I chose here the smallest. If you chose the largest, doesn't matter in the end, as long as you get the cells out. So I chose here the smallest, which causes these particles a bit. So as explained in the pipeline itself, the particles are a bit noised. So our auto thresholding will find these as basically one block. And as you see here, these are detected as is. To get better detection than that, you usually have to go with deep learning based things. They are very good at it. So if I want to get even better even better segmentation out of that, I would use this upper cell pose. Cell pose can detect these very reliably if you give it a good estimation of the diameter, and then you get directly out the ROIs, and they are also already split apart. Although you might hit some limits, so it depends on the data where you might hit a limit in cell pose, and then you are supposed to train it to teach it more concepts. So what was generated was a visualization in the end. And let me check if I did this one actually here. So you can use this set overlay. Oh, I made actually, I did not adhere completely towards it. You see that I tried a bit, played a bit around with that first. But what the original pipeline did was to create a visualization. And you had two options with that. So either you have set overlay, and then you give it the ROI, and then the original input image that you wanted to draw it on. You feel free to draw it on the Z stack, which sits here, but you better see it when you draw it on the focused one as well. So when I do this set overlay, then everyone also got this, and I see the pattern in the code when you have this, and okay, it's there. The set overlay 2D in JIPipe is a bit different than in ImageJ. It will, when you save it out, render out the ROI with it, but you don't have control here over how the ROIs will look like. To actually have control over it, for example, you want to recolor the ROI, you want to change the thickness, you can use convert ROI to RGB or convert 2D ROI to RGB. This renders it out directly into an RGB image. And then you don't have the ROIs accessible anymore, but they are now as pixels, and then they're 100% sure when you save them out that they are generating the ROIs with outlines together. The a bit later, when I go through the joint one, I can show also the solution where you actually, the set overlay would also work, and where you can actually modify how the ROI will look like. Well, actually, let me get rid of all of those because I can use them later on. These were just my tests. And I can make them live for you. Which one is what? Let's do this. Because this was my test thing. So now we have it like that. So this is a bit cleaned up with the two different visualizations that are possible. And then I think no one forgot it in the end, but if you replicate actually the pipeline as it says in with the macro, and then in the end in ImageJ it's also described that you save it out as file, then do so. So use the file exporter, so export image, to export your visualization out into a file. By default, it is configured to go somewhere. The data directory is a directory that JIPipe makes when it runs actually things, and the auto file name is an automatically generated file name that is empty if you don't have annotations. This is some quirk of these. So technically you don't get out a proper file with those. So when I open the path up, then it goes here into exported image, exported file somewhere. So I accepted those, but in the end you want it maybe in a good path that you can actually find where it will go. So for example, I want it named exactly as my input in some way. I can go to export image and then use this select thing and save it, for example, into task 1 outputs single or something. And then I save it out as this TL visualization. And it will ask you if you save it next to your project or next to a pre-configured input directory. If you made one already, even though it was not part of this task, absolutely fine. Then it will suggest you to auto-write the macro, the expression. So I clicked yes here, and then it auto-created basically used this path combine functionality to make me a final path. You can actually see where it will go when you are at the log or you read out the file that comes out of it. So again, as when you're processing files, when you're listing files in the beginning, you can get these out and then look at them. They're just paths, they're not the files themselves, so just the address to the file. And then you can check if whatever it did is correct. So of course, this expression language is a bit complicated and is a step up in in requirements, but you get used to it, and you can also play around with it a bit more interactively when you use this calculator panel here at the top left. And for that, I want to show you what, for example, what happens here like that. So this. In the expression language, everything that is orange is a variable. This means that it's a placeholder that will be replaced when this expression is executed. And when it will be executed, wait for the zoom. So it will be executed per data item, so per image basically that goes in to basically generate a path where it will go. And some are a bit confused about this path combine functionality. It's basically just a helper function. Because when you build up your path manually, for example, if I could just do this, your task 1 outputs single, could go in there and copy the path out. Windows style path, great. And then basically type this in, but I have to replace the backslashes under Windows with a /, otherwise it breaks. This is why this auto functionality is quite nice and helps you. This is just some detail of Windows. So what sometimes happens is when you have like a path typed out and you want the you can concatenate them, so you can basically plus it, and everyone used it at some point. For example, I can make it like that output or something. Then what it would do is, if I execute it, it would make like a combination where it I need a new one. Where it basically just puts it together like that. Output single output. But then it would go in here because it's in task 1, and then it would make a file that is called output single output. But we want it to be in output single. So we need to add, we need to be careful to add this path separator in here, so a slash, that we tell it, okay, please put it into the output single directory and not make a new file that is in task 1. And this can be quite confusing over time, and then you might need to forget it, and then it's cumbersome. And this is what this path combine actually does. It helps you with doing that. So let me, for example, if I can, I show you a bit longer path combined. So I can use path combined, combine, and it needs to have like a, I need an editor there you can see it better. So for this path, it's helpful to do it maybe in the editor, and then you can see it better. Path combined, and then it opens a brackets, basically telling what goes into this function. And the editor will then complain that you have to close the parentheses. So you have to do it like that. So this one doesn't do much. It does basically the same thing, but the strength of path combine is that you can basically separate the directories with a comma and then make always your intermediate steps in quotation marks or use other things. So for example, you can path combine output and then visualizations and then transited light, and then how was my file called? Like that. And then when I run this expression, then I get a string out that looks like that, where basically you see it added between the output and the visualizations and the TL. It automatically added these slashes in between. This is its function, so you can just don't care about the slashes because you usually have to be very, very careful about them. Otherwise, it goes somewhere else. So get used to it, and then later on, when you use a variable like the image, I can make one artificially. For example, when I have batch processing, and you have a data set that actually is called my image. Then wait, why is it not working? Well, I try it out again. Okay, I did it without the hash because it didn't accept it. And then I can use in the editor, use it instead of my custom typed out name. So instead of this phagocytosis thing, I can use image. It is also detected here as a variable. JIPipe will help you if it knows about it, but often it doesn't know. And then imagine this is some batch processing, and this image is always replaced with the annotation that you got from the current image it's working on. When I accept it now and run it, then okay, this is a bad name that I called it my image, but it's now using the value that is behind this image variable. And then this way you can build up your paths easier. But it's it needs some time to get used to that thing. But it's very powerful in the end. You have then a lot of control. And especially this auto file name is convenient for the start, but later on you want very specific way how the outputs are generated, because imagine you go back like in 3 months and you want to check out the results. If you did not organize this properly, then you don't know what is going on in there anymore. So come up with a good structure of basically everything, and this will solve it later on for you. So I have now my visualization out, and then it was also requested to have the ROIs and the measurements out too. So I can use export table. Export table as Excel is also fine. This one, the difference between these two is that the export table as XLSX, it can make a multi-page Excel file, so where you have multiple tables inside. And the export table makes just one sheet in Excel. That's why it can also save CSV, which is its default. So if you want to save it as Excel, you have to tell it. There will be some change and some added thing. I wrote it down that you can easier find this functionality later on. So I save out my measurements here. And for that, you can just often copy and paste everything. So you can copy these paths in there, TL measurements. And then the same for the ROI. Everyone did this as well, like finding the ROI exporter. Get the ROIs out. If you named it the same, then anyway you will have like a TIFF, PNG file, a TIFF file, and a zip file, so it's going to be okay. If I run those, they will run. Export. And don't be surprised that the ROI file is a zip file. This is just how ImageJ saves this. This is the official ImageJ format. The zip file itself contains .ROI files. This is just how ImageJ does it. Just accept it. And then we do the same thing for the other branches as well. So for the EGFP branch, it's basically the same. We can just lazily copy it. So I don't have to rewrite everything. And there I, no, I don't need this dumb overlays. So I save some space with it. So I get the overlay, draw it on top of my C projected image, export the measurements, export the ROI, and then check if it works still. And what you notice is it always keeps importing the image again and again. Because when JIPipe goes and runs something, it will basically track backwards and then search for a way to maybe avoid importing things or rerunning things. Here is none set, but you can do what you can do is intelligently cache stuff that you will reuse all the time. For example, we have here this C projection and the custom depth of focus. If you go and then I'm selecting all of them, you can of course go it one by one, and I cache these with update cache. So JIPipe will include them then all. You can cache multiple things at once. Then the tool will keep the C projected image in there. When I run now something that relies on it, for example, this histogram contrast enhancer, when you run it, then you see it did not import anything. It basically was instant, because in this thing, when I tell it to run, it will go backwards and then, oh, the C project is already there. I don't have to do anything else. I can just take what is there and then continue from that. JIPipe will take care of that the data is not accidentally overwritten. So this is then convenient, and then this way you can prevent it from repeating stuff all the time, and then speeds up your analysis a lot. So, and then I have here my visualization, but I just have to change it from TL into EGFP or something. EGFP. The same here. And then now the third one, which involved our correction for the I need to disable that because I want to make some space. Space is always nice. So there's some functionality. I showed it to some when they had made the when they drew here like these outlines. There's a little button up here next to this undo. So for example, I can move that one around, but if I click that button here, it's a little one, then my mouse doesn't hit into these annotations anymore. There's like an alternative way to locking them, which you can also do. So the CY3 and CY5, as Sultan explained, these have crosstalk with each other. So we have to do a bit more. So and everyone did this correctly. So we have here the follow just the guidance of the algorithm. We do basically the same as before, and at some point we have an auto thresholded image for each one of them. And then what is requested from the workflow is to apply a morphological closing, because the morphological closing helps us, for example, with some, for example, here, this one has like a little pixel here missing inside, or here this part. And the morphological closing would basically close this. It's in its name. It closes small little holes. So if I compare that and go to the same part, here's the hole is not anymore there. And then also this part is a bit more connected now. This is the aim what this closing does. And the same for the other path. So it's closed and so on. So as mentioned, this one has cells that are, so let's set it to focus mode. You can always click in these viewers at the bottom right little button, then it will basically hide the whole UI from it. So you can see it better and compare it. That in the CY3 image, we have also all the cells that are in CY5 approximately. And this is why we had in ImageJ, we have only the option due to the lack of ROI overlap filters. And I did not want to confront you with that. This is like a 500-line macro to do this in ImageJ. Or you can click manually through each cell. This is not fun. And to get rid of it. And then the easiest way is we take our image where our exclusive objects are. To get rid of those same objects in the other one is we basically subtract from this one the other one. So this is why this image calculator was there, or the fast image arithmetic. Some people use the legacy image calculator. It's absolutely fine. Does the same thing as well. So like the ImageJ one. And but if you do it without any processing, so maybe some try this out. If I set this one here to pass through, you will see it. The pass through means that the node will pass just the data through itself and then doesn't do anything to it. We get a lot of these pieces that are left over, and these are not nice to have. We can filter them out, but another valid way is to just take this mask here, and then we dilate each object a bit more. So make it a little bit larger, inflate them a bit so we have additional space around them. And this is what this dilation with radius 3 or 1, depending on where you checked it. So in the interactive one, it says 1. Absolutely fine if you chose also 1. This was a mistake. Or if you played around with the parameters, absolutely fine. I don't go and check 50 nodes. I just want to see that you have this structure. If you do this, then we don't have these weird pieces anymore. And like everyone did this correctly. What not everyone did correctly is this one here, our dilated image. This is basically an eraser. It erases only things. We modified the cells. The cells are modified. This here belongs not really into this path. It belongs to the other side. And this was a mistake that some did, to continue working with the eraser and then do it with, apply the distance transform watershed on that. This is not the case. We used in the macro and in the image instructions, we used the closed image, not the closed dilated one. So be careful with that. Remember this with the kidney that I showed you in the lecture. We can mess up all our statistics. So imagine you have something where the cell size is important, is an important measurement, and then you dilated something because you used it as an eraser. And then all your statistics is shifted up, and you might derive the wrong conclusions from that. So maybe position the nodes in a way that you don't do this accidentally. I did not reduce any points, so it would be like minus 0.1 points or something. So it doesn't matter. I gave full points to it just so you know that it happened, and then organize your things always nicely so you don't get confused with your steps. With these visual languages, all of them are like that, is that you sometimes can get confused with them where stuff is and where stuff flows. Just in its nature. And then we can just continue afterwards. I think no one also forget the distance transform watershed to split apart the image, to split apart the cells, or try to. Distance transform watershed is not perfect in that regard. For that, you would need cell pose that would actually be properly working. And then we do the same thing for our visualization and exports and everything. So give it my ROI, give it my measurements, and don't forget to change the files. Again, auto file name, absolutely fine, although it would go somewhere, usually CY3. I did not use points on that because at some point you anyway noticed that the auto file name or wherever you put them, this was not doing it completely how you wanted it when you're doing batch processing, although there the auto file name works actually. So, and then CY5 as well, and the measurements too, CY5, and then we get everything out in the end. So, and then that's why I can already talk about it. That's why there was this task as well to have it somehow output. And for example, you want the outputs now here, and you have to select all of these output nodes and then run them to get all your files. This is quite cumbersome in the end. So if I run all of them, then it ran through, and then now I have hopefully all my results here. Looks like it. So always 3. What is with that one? Oh, it's fine. It just looked weird when you see the thumbnail. And then now we want to make this all-in-one visualization, which you can do easily in JIPipe. So the one that I suggested to you when I got asked how you can approach this is like stacking convert ROI to RGB onto each other, which is what you absolutely fine. It works. But there's actually another solution that involves a bit of ROI processing, which I had no time to really explain. So let's make me here the task 1.4 all-in-one visualization. And then what you do is, for example, you start here with the transmitted light image. And then here I make actually a duplicate because then I have a nice and tidy. Some used here this one, and then they went wild over the whole pipeline. And I looked then for the pattern if you stack them on top of each other, and then hunted for your convert ROI to the ROI to RGB, and then I knew when it was the pattern that I saw. So absolutely fine if you did it like that. So we have our transmitted light image here. You can choose the colors how you want. So for example, the one from transmitted light, I can override the line color to be gray or something. Okay, this is a little wrong gray. So lighter gray, so it's a bit better visible. So there you can absolutely update, cache it, and the viewer will update itself based on it. So you can keep these viewers open. And then you would continue and we stack now the other channels on top. We draw on the convert ROI to RGB, another convert ROI to RGB, another convert ROI to RGB. And then we give it the different ROIs. And then let's give it the eGFP ROIs, and then the CY3 ones, and then the CY5 ones. I need to zoom out a bit more because I'm too lazy to use this other connection function where you can connect across the long distances. Let's not. I have to set the 100 in, and then just change the colors. So this was green or something, and then this was orange, I think, and then this one was red. And in the end, we should have the all-in-one visualization with everything. That's actually how I made the one that I showed you in the sheet. I just used JIPipe for it. And you see the one, and then it was not requested to do this, but would be of course fine if we have it exported as output. So we can go here and then name it the all-in-one visualization. So we have it here as well. And it opens on the other screen. But there's actually a nicer solution for that, because we stacked a lot of blocks here on top of each other, which is like a funny looking tower. But what you can also do is involve a bit of ROI processing and merging the ROI lists together. So this can be then more useful if you have more ROIs than just 4. Also, this opens a few opportunities for you to do some additional processing on these. So let's begin on the ROIs. So we have here our fine particles 2D, and we always grab the ROIs directly out of them. But maybe don't do. Maybe we want like something like, okay, this is the final ROI. Maybe we can set the color of the ROI already. As if you use the image here, you can go and select ROIs in the ROI manager and then change the color there of the ROI. You can do the same in JIPipe actually with different kinds of nodes. And the one that is interactive is change ROI properties, or I forgot how it was called. Change to the. I forgot. Sometimes I rename these and then I forget how they are called. So it's in ROI modify. I renamed it into set to the ROI properties. So this one, and then this one will be for our TL. So this final ROI TL. And there I can have the same settings as in this convert ROI to RGB, but then it applies it only to the ROIs that we put in. So I can tell it already here the line color should be this weird gray, or maybe put it like blue, then I can see the difference later on. And then we feed it the ROI in from that side here, instead of having like 15 millions of those going out. And when I update cache, you see already in the preview that all my ROIs are now colored blue instead of yellow, because they carry the information of being a blue ROI inside of them. And now we can do basically the same thing. So I can grab the transmitted light, the eGFP ROIs. Let's organize this a bit nicer. The eGFP, and these were green. Then the CY3 ones, and these we set to orange. This orange here, and then the CY5 I also grab out. These are red. So we have then now all of these roy lists, red, orange, green, they're there, but how can we, what can we do with this? We can take basically these roy lists and then merge them into one big one that has everything. And there's an operation for that. It's called merge roy lists. There are multiple ones, like there's an ordered one where you want to have ensure that there's a specific order. Then there's a pairwise which matches up each one with everyone, but we want just a normal one that just says merge to the roy lists and nothing else. It has multiple of those. So we give it all of those at once. So 0. And then what happens when I run it, I get a roy list that only one that has 151 items, and it has all of our roys in there. In there. And then this way you can also export, you can, for example, use this totally for multiple things. For example, have one set of roys that goes only out per image. And then how you differentiate between the roys, you use this roy editor, and you can set the name in there as well. And then this way you can them later disassemble, pick out parts that you are interested in without having like 15 different roy lists, depending on how many conditions you handle. So we merge this one roy list, and then now we do a convert to the roy to RGB only once on that one, on whatever image you want to render it on. For example, the transmitted light thing here on top, but I really don't want to drag a line. But actually, this find particle, find node here, find matching node, when you double click this, it can also find for us existing nodes as well that are already in the pipeline. For example, if I search here for the extended depth of focus, it is the one somewhere at the top. This is exactly that one. And then we can directly connect it across the whole pipeline via this functionality. You can also right-click these and then connect to, and then there it would give you a list that is ordered by distance. So this is also another way that I never explained how you can make long-distance connections in JIPipe without zooming in and out. Sometimes zooming in and out is easier, and sometimes using these other functions are. So and then now we get the same, but it's fewer stacked nodes. Yes, we have these additional operations here, but these roys are very handy that they are also pre-colored now. We can name them as well. So this is maybe a good idea to have that. And then I also exported just for the sake of completion, version 2. And then it will go into my folder. And this one you can differentiate because it has these blue cells instead of the gray ones. So, and then everyone did this correctly at some point, the table with everything. So where we have a table with the individual roy counts. And for that, I had given you this sheet. Everyone did this, where you got explained how to do actually this operation. So it's count roys, count 2D roys that will do it. Let's make me some group here. So I can put them here. Count roys, task 1.5 and 1.6. I will do them in this box, both. And as explained in the instructions, and everyone understood this, you give it what, based on whatever is the input slots, you give it the roys, then it would make a count table with named according to how you named these inputs. So but here there was some confusion sometimes where people took, for example, this counted roy and then right-click it and then label it. For example, they labeled that TL. It would not use this label information here. Yes, it says TL, but it's actually a labeled roy. It's slightly italic. So when you see it in the name, it is italic. Hard to see sometimes, but in the slots, it will tell you the actual real name. So when you select the node and then go into the slots panel on the right-hand side, it says the real name of the node and then the label. And the system with the labels is there because you can just type in anything that is not allowed even for these names. For example, I can't use chevrons as a name because this has a reason for a technical reason. So but you can, instead of labeling them, edit them actually. And there you can actually set the real name to it. And you see here TL with no label and so on. TL, EGFP, so everyone anyway did this correctly. CY3 and CY5. Straightforward. This one, this one, this one, and this one. And you have this big brick of death. Sometimes I call these when you have like large ones that go together and pull apart many. And don't forget, as it says there, export this please as a table. Add this in. And then give it a name. So it's like measurements like white counts or something. Or just counts. And then we get out the table in the end. And then there's a more advanced operation of that one. We want to have overlap. Everyone did this also correctly. JIPipe has these ROI overlapping nodes for exactly that. And they are hard to explain. Usually for the people who I started, I drew some some drawing what they actually will do. I hope I can somehow translate this into this presentation. So let's overlap filter 2 divided by overlap it. So it has ROI1 and ROI2 as input. And many struggle with this node in the beginning. So here you can really make use of this label functionality to really help your mind a bit as well. So it has ROI1 and ROI2 and an optional reference. The reference is used if you want to go into this node and then you want to customize what the actual overlap is, how it is defined. Because here, when you click edit, you have access to annotations or variables that are obtained from statistics. So you can give it like an image channel or other information from an image as a source for the statistics and then use this to come up with an overlap condition. This was actually used multiple times already, because then what is actually an overlap is highly dependent on the data. We here use just the simple one where it says, okay, if it overlaps even 1 pixel, then it is 1. But for the filter here, it allows you to even add more of those in. So you can browse through these. There are a lot of settings how you can control how this node behaves. It is very, very advanced. So what it will do is, for each ROI1, as I explained for everyone, it will get it will output only the ROI1 where that overlapped with at least one from the others, or from the ROI2. So, and for that, we can maybe use the label slot to help us a bit. So I give it here my EGFP, and I give it here my CY3. So I did not rename it, I labeled them so I can keep track of that. This is very helpful when you use this node the first time. So ROI1 is, if you follow the definition, it's the EGFP that overlap with CY3. This is what comes out of ROI1. And ROI2 is the opposite. It is the CY3 that overlap with EGFP, so at least one. So maybe I can relabel this with at least 1. And then here also just to write it out, each with at least. And this is what this node does in its default configuration. You can totally change how it behaves actually. You can do it actually the inverse as well. With this node, you can imagine it that it says that it does the inverse, which you can do here, tell it to invert its behavior for a column basically. We can do a better version of this erasing here. Actually, we can tell it, okay, please remove all those which, or only keep those which don't overlap with the others. In this way, we wouldn't modify it with erasing or maybe cut something off. But let's first focus on the task. So I give it the EGFP, which is here, this one, and the CY3. And then we get only the EGFP that overlap with at least one CY3. And then for free, we also get the CY3s cells that overlap with at least one EGFP spore. And then we get the other one. So you have a long brick again. But then this is CY5. CY5. And it takes some time to get used to this now, but literally, if I look this up, I checked if I am actually, if I should confront you with the same in ImageJ. I decided not to, because no one knows actually how to do it without a forever long macro. And then if you ask how you can do it interactively with the graphical interface, they say, yeah, you go to the row list and then do it manually one by one, and then delete them. So this is no fun, and I did not want to do this either. So, and then we give it the EGFP, and these are not the CY3, these are the CY5. CY5, and then we have them. They find 0 on this data set, which my image was created on. It's absolutely fine if it's 0. It is just like that. Then. And then some others used other data sets, and there they found actually something. So, and then we added our search again with the width, typed it wrong here, with CY3. Why is it? And then the width CY5. And then we count them, and then we should have exactly the table that we got out here with 2 and 5. Don't forget to export it out, and then this is the EGFP CY3, CY5 counts or something. Come up with good names for these, so you know what you did there. And then it's basically task 1 done. You didn't need to do batch processing. If you did batch processing, if you did compartmentalization, fine. That's why I wrote your pipeline should fulfill these conditions. If the conditions are fulfilled, then they are fulfilled. If you fulfill more conditions that you did all by yourself, fine. Then, and I also did basically searched the best answer for you. For some broke accidentally the pipeline when doing task 2, and then, or they fixed something in task 2 which they did not do in task 1, and okay, you did it, and then I gave you full points because at some point you did it, even though it was not done in the task 1 file. So don't worry about that. That's what I meant. I'm lenient with these. So task 1, and then we go to the questions maybe first, because they are anyway here. So the questions, I was extremely lean with those anyway. Everybody was tired, including me, and I graded this at like midnight. if you gave me some answer, then where I wanted to see I wanted to just usually see some word or some concept or just your ideas on this. So it's absolutely fine. Because if you just most did their best, I think, with that, and then I'm fine with it. So then there are some very nice comparisons. What are the benefits and disadvantages between providing macros versus sets of instructions? And you can imagine the macros are, of course, very strict already, and they are very well defined what they do. You cannot find inconsistencies so easy. For example, in the instruction set, there might be some misses, like with mine that I gave you, where I missed some parameters. Maybe someone forgot a step in the macro. You can rerun it all the time. You can test it easily if it actually runs, and then see when you develop it if it does what it should do. With these instructions, you can easier miss steps that you have missed. So, but they are easier to follow, maybe for some people who are not familiar with any programming language. Then for question 2, the rolling release model. So what I noticed, there are some people mixed up ImageJ and JIPipe a bit. So JIPipe is a plugin for ImageJ, relies on ImageJ, but the JIPipe has actually not a rolling release model. Unless you install it via the ImageJ updater. But there's a reason why JIPipe is on JIPipe.org. When you go here to download, you can go back until 2020 or whatever, until it was released first time, and get that specific version from the time, because it's actually properly semantically versioned. So the current standard of versioning. So if you install it via the update site, then it is rolling release, because then you will always get the newest one. But you are absolutely fine with getting JIPipe. You have a pipeline that it was made for JIPipe 4.1. It says inside the JIPipe pipeline in the text, and you open them up on which it was saved, and you can get exactly this version with that ImageJ from what it was tested on. And then and this is a bit different compared to ImageJ, where you always get the newest one, and sometimes you get the newest bugs too, in whatever experiments they're currently doing. So the disadvantage, of course, then of this rolling release model, and it would not be the first time that this happened, is that stuff breaks. By developing JIPipe over time, I have experienced many of these bugs from ImageJ's side that were suddenly introduced, and then they broke literally macros. Sultan's macro broke when they suddenly changed how series from multi-series TIFFs are put into the image title. Everything broke. The tables broke once. Now they have this whole Java 21 update thing that breaks the 3D viewer, or it triggers the virus scanner, or some things just don't work randomly. And then you hit update, and suddenly other things don't work, or other things work again. So you are never sure if your macro will 100% work. And I think there's currently a problem with Mac OS in contrast with thresholding, where the thresholding behaves different to Linux and Windows and Mac OS, and no one knows why exactly. Then you have question 3. So I'm fine if you mentioned any of these. I think everyone mentioned this. Then the rolling release model, what is the current safest way to ensure that the macro works on another computer? Some had some interesting solution that I accepted, like from a completely different angle, like sending it via mail. But this actually would not ensure that it actually runs on a different computer, because the macros, anyway, you can upload it Google Drive, you can send it via email. If the ImageJ broke because they had a weird update that broke something, then your macro still won't work. Actually, some others had a good idea, have exact versions of ImageJ and exact versions of the plugins. The problem is there, unfortunately, ImageJ doesn't have them. There's someone, hopefully, working on the so-called Fiji time machine, and they are aware of that issue, that you cannot go to a specific snapshot of ImageJ. You are updated, then you are updated forever to this specific version, and then you can't go back. They're working on the Fiji time machine that would allow that, but I think this project is stalled and not continuing, so really. So it's like stuck somewhere. The actually only safest way currently, unfortunately, when you're publishing something and you want to ensure that someone runs a ImageJ that you worked on a macro or a set of instructions, is to actually zip it up and then give it to them. So you have to really compress it into a zip file and then you give it with the data. This is the only safe way currently to do it. Or you base it on JIPipe 5.2 and then tell them, okay, use the JIPipe 5.2 ImageJ. That's also fine, because JIPipe's ImageJ does not change between versions. There are always copies of that version from that specific release date, and they're never updated. These versions are left alone, and then instead, if there are some bug fix, a new version of JIPipe is released that has something updated. So then the benefits and disadvantages of ImageJ versus JIPipe. So there are many good ideas. ImageJ is, of course, more approachable. It's interactive, which is easier to understand. In JIPipe, you have to rethink, and I think everyone here experienced that you have to think from a completely different angle about how to work with some commonly accepted things like files, folders, that you have to first put a set of instructions and then think a bit differently about them, and not see immediately what happens with each step. So making the process easier, there were some nice ideas that I will maybe incorporate into JIPipe itself. This is why I asked it, actually, your feedback a bit about that, so I can come up maybe with some ideas that help people. There's actually, I can already tell you, a project going on starting very soon with large language model for JIPipe, so a ChatGPT for JIPipe that we would train on DeepSeek probably. And the idea is then that this tool would then help you with your issues if you want something specifically done, and then you would ask, okay, I have this and this and that. How does it look in JIPipe? And it would then make you the nodes that would do the task. This is the idea, so hopefully it works out. So task 2, making everything batch processing. And I split it up a bit, so I have a bit of way to give you some points if you maybe did something wrong in later parts. So usually you get, when you do, if you did your project smartly in some way, where it is compatible with adapting them easily to annotation-based processing, you basically got task 2.1 and 2.2 gifted by itself. But for 2.3, I checked if you actually edited the exporter nodes and edited them in a way that they actually export multiple files and don't overwrite stuff. So if you missed one, it's fine. It's like, can happen. This is just on you, that you have to be more strict on your data organization and going through it a bit more carefully. But then if you missed one or two, I don't care. I just wanted to see if you did it a few times. So I see that, okay, you have understood the idea behind it. If you actually, funnily, if you left it at the default setting, project exporting it into the data directory with the auto file name, then the auto file name would work, because then now you have annotations. And there you get it for free. I never said where you should save it. It just should be saved out somewhere. So for these tasks, and many of you did this anyway, and it was requested, take your project, just save it as another one, and then you leave the task 1 alone, and then you can play around with your next project and break it. And if it breaks, then you can just go to the other one. So what most of you did was, okay, we have these 4 channels, and then we give it the channel directories independently. So we give the C0 like that, and then do this files, annotating everything, and then so on. This is the standard way, accepted, but there's actually a better way how you can do it, a fully automated one that where you just give it the inputs directory, and then it auto discovers the channels, and then auto assigns it to the correct branch, basically. And for that, I go a bit up here, because you need some things for that. We start not at our channel 0 or something, we give it the inputs directory as itself. So it doesn't do anything yet, there are the inputs. But now, when we do find match, create new, list the subdirectories in there, or list the subfolders, then we have the individual channel folders in there. And now we make use of the annotation tools and remember this file or directory name. So annotate with name, file directory name. And then it would remember, I leave it as first in the default settings, the channels, but if you don't change it, as hash dataset. And then here is the thing to make it work. We don't make a hash and just call it channel, because they are actually all from the same image. The image file names are all the same. They are the same image, just split apart into different channels. And this channel thing here is, we only remember where it comes from, but later on when we are trying to combine channels, then JIPipe doesn't find it, because it will also look that we combine the channels, only the channels with itself. We can highlight this maybe later on, what then happens. So let's maybe run it with some had this issue where they had a hash there. And with one change, I can change it. So we remembered now the channel. Now we have these, basically, we are basically in each of these channel folders. This is where JIPipe is. It is basically sitting inside here, waiting for your instructions. And what we're going to tell it is to please list all our files in there. And everyone also did this in some way correctly. So list files. And I'm using one of these pre-made filtered ones that it only really gets the TIFF files, because imagine there are sometimes some additional files in there. Some tools generate like XML files next to these. You don't want to load them as images, because then you will get an error. It is pre-configured to only look for TIFF files. And we get all of them, all 24, but each one has an annotation of what the channel is. And then we can basically have 2 routes. We can basically take the list files route, and then we can either filter these files now, or we can tell the list files to filter them for us. Because here, when I run it, it has access to the annotation. So theoretically, we can already do the channel filtering here. But I'm doing another way that no one has seen so far. We use the split and filter annotation node. So there's a split filter by annotation. It is a node that gets any data, and there we can basically make an array of filters, like how many branches we want. And let's set them up. It has outputs that can be configured. And let's say the first one is channel 0. The second one is channel 1. Why is it a ROI? It should not be a ROI. It's an image. No, it's not an image. It's a, which I just say it's a data, then it's easier. Then a channel 2 and a channel 3. And then when you add these in, you see on the right-hand side, you get for each output a filter that you can configure. And there I'm gonna tell it that only give me out into channel 0 the files where the channel is 0, which comes directly from the folder name. And then I just do the same thing here, but change it all the time. And then when I run that, and I can select which channel I want to go, I go to C0, and we have 6 files, because these are the ones that are coming from the channel 0. And I now see here that I forgot to add the annotation node, the actually important one. In between, I need also my annotation thing again, because I have to keep the file name basically. And don't forget to rename that if you copied it. So I call it here this time image. And then in the end, we have for each channel the ones that have the channel information and the image information too, from which file it came. This is basically now we have files. These we can just connect directly without anything to the import image. We have like a big branch going on. So we have them split up. And then when we run it, then it will load 6 images instead of 1 only. And then they all know about their channel where they come from. And if you do it like in the beginning properly and you have it annotated nicely, you basically get everything for free after that. And I counted it as that. If it worked, or it would work, because I did not run everything in the end. I just checked if I see the patterns of the hallmarks of how a workflow that looks like it will work. I know what the patterns are. Then it will generally work. For example, you can go here to our find particles 2D, and it will still run everything, so it loads our images in. Maybe I should here. I will later anyway have to cache them again. 4, 5, 6. And then, so we get the 6 ROI sets for each EFP and everything. So now we have here one problem. And this is what everyone encountered who has some of these channel merging style ones. If they run into issues with the fast image arithmetics. So when I update the predecessor cache here, which will just cache its direct predecessors, this is why it's exactly there to test out an algorithm when you have to retry something or there's something wrong with it. In this way, it will save only the stuff that it needs directly, and then this way you can test out the algorithm without manually caching it. So in a minute, it will be going through 5, 6, and then the rest will be fast. So the input manager will tell you there's something going on with that. Why does it look so weird? To check that. So it will work because I have it wrongly annotated. C1, C2. Why is it like that? C channel 1, C1. Channel 1, C2. Maybe okay, I have made a mistake here in the split and filter. I forgot to edit it. So I've forgotten to edit it. Cancel all tasks. Let me check again if I did it correctly. Yeah, okay, now my whole concept has been destroyed. So I am caching these. this because they always take forever to load. So where is it? We have to check if it's this one has some issues. So this one. Yeah, I should not have done that. So loading all the images again and just to be sure. Sometimes you can hit these cache mistakes. Sometimes the thing does not remember that you changed something, so especially with some more complex nodes. So we have it now. And then if I cache in the previous ones here, five, six. I include so many of those. So inputs. C3 and C3. What? I checked the wrong one. So you will get this error where you have missing data, basically. So there's something weird going on with the segmentation. I have to check that. So where something did not match up. And why is this the case? Because it uses both the channel and the image as a way to differentiate between the data that comes into that. And this is one big issue that can happen in this case. But the channel information, we don't care. So a quick fix solution would be to just remove the channel annotation here. The easier one would be just you go way back up and you just don't do it with hash. We just do it without hash because when do we use the channel? We use it exactly once here and then nowhere else. So we don't. We have to carefully design this sometimes. What is actually important? What is not important? So image and then channel now is set up in a different way. I just want to check if it worked. And then if I cache these two, then it should work immediately. And then also the fast image arithmetic should work. I just have to check why my see there's something with the filter going on here with the thresholding. 5, 6. So, and this one is there. So now check why. Okay, these are detected. These are detected. Okay. So results. Then we have the fast image arithmetics. So it usually worked, but don't forget that if you're working with scale images, then it's maybe a good idea to set the fast arithmetics to 8-bit. Then it does not make negative values. And then it will work again, but for all 6. And then you basically get it now for free to generate the things. Saving them out, for that we need a bit of more settings now, setting things up. And yes, this is cumbersome because you have to go through each exporter node and then basically modify them. But what you would do is modification in this path combined thing is if you set this up correctly. So let's say it's outputs multi. So we have them separate and then one can check if everything is okay. There we don't want to use the comma because then, although we could theoretically use it, but I want to use only the Should I be super lazy and just use channel information? I know it will be combined. So dataset. So auto file name would be fine, but you have more control if you do it yourself without the auto file name. We just use here instead the dataset. And I checked this if you have at least the auto file name in there or you do it properly. It's like a few people actually did it nicely and have some super nicely organized outputs set up. And then some just use the auto file name, which is also acceptable. But when you gather annotations in your with this auto file name, it will absolutely add them in, and then you enter up with monster file names. And this can also, and there's an issue when your file names are too long, is that they hit the limit of Windows. Also, Windows has a limit on how long a file name can be, basically. And then if you hit it, then you get weird errors where it says it could not find something, or cryptic error message. Although you get used to at some point to reading them and you know what they mean, because you can find like a keyword in there that corresponds to some specific condition. This happens usually with these all-in-one things here. So these are also, and this is really important that for the all-in-one, you should be super careful what they do. No, these are actually fine. All-in-one is fine. And also, I exported them accidentally all into export single. Doesn't matter. Did I? Single. I did it only once with multi, and then I just changed it into single. Because I'm too lazy now. The dataset, and then also modify that one. So it can be cumbersome. This is why sometimes when you organize the project, it's a better way if you just started organizing properly from the beginning, and then you don't have to do it the cumbersome way. So what happens here with these counters is something interesting. Why did we import my image? Because it made the visualizations. Why is it? Because I only cached these two. So when we have here these counters, what happens? I forgot that for free it is auto-configured to automatically merge it into one, basically. And this is mentioned in the lecture that there are some settings where you can actually, some nodes will not do this for you, where you have like a one nice all-in-one table that does everything for you. But this one does it, and I forgot it. But so you got this totally for free if you just hooked up all your batch processing from the start properly. You see it here when I open this table, because it will also add all the annotations into it. It made here like a weird hybrid of this channel, because it combined them multiple times over the whole pipeline into like a monster annotation. And this can mess with your export table later on when you use this, the auto file name, for example. There you really need to take control of it and then say, great, this is all my counts. And you have to give it a proper name that does not depend on the annotations, or where you really, really select which annotations it uses, because they can be like such monsters here that Windows does not like. Worse with the images. So when I copy here this value and then put it into my thing, then this is the line that it made. This is so long that you run over the limit of Windows, depending on where you save everything. And then you get weird error messages. So we are not gonna use this at all. And anyway, it's a good idea to name them like all-in-one or something. The same thing with the other count here. I just call it all. Don't use any annotations here because they break more than they help. The same with the auto file thing. And then we get a nice Excel file which is nicely named out of there. And then for more complex workflows, there you have, like, for example, we want a table per condition, but each condition has multiple images. There you can also have a bit more control and then determine, okay, which ones you want to use and which ones you don't, and then by which one you want to split. But this is very advanced thing. So, works now. And we have exporter nodes are working. The 2.4 you get for free, just ensure that it will run. And 2.5 you also get for free. So basically, when you did the 2.1 properly and then 2.3, you checked all the exporter nodes, you basically got this whole thing for free. So let's talk about the questions that are associated to it. So the batch processing system can be used to extract information. And what is the way and how they usually break. And this is very common, and everybody, I think, answered this correctly. JIPipe, the JIPipe, when you design, expects a specific structure of how you organize the data. If someone decides that the structure is now different, then you have to edit the pipeline or it will break. And this can not be only structure of files, but for example, if you were in the mood to change the channel order of your image, for example, then we have pipelines around that have a gigantic file handling compartment just to handle these. Because then, okay, in the file name, if this is in there, then the channel order is that. If it has some other things in there, then the channel order is different. So maybe don't change the channel order. Then your pipeline that you make shrinks from a gigantic monster where you have to handle these different conditions into something that is straightforward, because you can just follow the structure of the files. And the same with the structures of your files, have this all standardized, well organized, where the information that you're looking for should always be in the same place in the hierarchy. And then you're ending up with a simple pipeline that does not need so much processing of the data. But this is then also one of JIPipe's strengths, to be able, if you have such a mess of a organized data, that you can actually make use of this regardless. Then you use these file processing nodes, splitting annotations, and so on, to somehow grab the data and then organize them internally in JIPipe via the annotations where they should go. And then later on you adapt to whatever conditions you have. And then, for example, split the channels differently. Then the system memory thing. So, okay, I accepted basically any answer there because I had no time to talk about this. So memory is important. So something that this clean memory here does, it basically just tells if memory that could be cleaned, then free it up. Because ImageJ and JIPipe, they are both inheriting this feature from the underlying toolkit. It does not like to free memory because this is an expensive operation. So it takes memory and eats it up until it has to really free it, because it would you would starve out of memory. And sometimes this is usually for your peace of mind in general. If you use this clean memory thing, it will not clean up the memory. If you have loaded 50 gigabyte image and then your memory is almost full with it, and you click clean memory, nothing will be working. Nothing will help, because the image is still loaded. But if you close the image, clear the cache, and it still says, oh, it's almost full, and then you click the clean memory, then it would tell basically the underlying technology, okay, now you clean it up, please, now. And then it would go down in the memory meter. So the actual way how you would handle memory management in JIPipe, some suggested it as well. You chunk your data yourself. You make, for example, smaller directories. You maybe can pre-split them. You want to only handle one condition or a subset. But there are also tools in there that I talked about in the slides that are a bit more advanced. For example, you have this partitioning system where you can take a part of the pipeline that should be repeated. And for that, if you want to learn more about it, there is a bit of documentation already there when I find it. Graph partitions, where you can, for example, say, okay, I am doing my file handling up here. And this one is a very memory-wise cheap operation, the same as visualization statistics. They can be cheap if you set them up correctly. But instead of loading all images in at once and then thresholding all at once and finding particles at once, I am basically telling JIPipe, okay, I get files here. Can you please do this part per file? So I don't need to load one image, and then I don't need only threshold one image. And then please collect what goes out here, like define particles to the output, something that is very, very cheap to calculate. And then use that as output for, and then forward this later on when you have collected them all. So this way you can reduce the memory. Actually, I see it here that this one doesn't reduce too much because I have here this convert all to RGB. But let's ignore that. Imagine here's like your Z stack, and then you have like a extended depth of focus or a set projection that would reduce the memory significantly. Then there it would actually be useful. It doesn't have the whole Z stack in image in the memory anymore, only this small 2D image. And then afterwards, you would then do the statistics when you have all the measurements together, because you might want to combine something later on. So this is a JIPipe's native way of handling, making something loop. Each group node, so the ones that I explained to you, they can also be set up to loop. So when you have a group node here that you add into your pipeline, in the parameters, you can tell it to loop over the data, and then it would repeat its content how many times by how much data you receive. This may be also a bit easier for the beginning if you have something that is very compact but very expensive memory-wise. You use the group node and then use that one to loop over the data. But there you don't have access to the cache, so it must be something that is like, okay, this works now, until I solve this issue. So back to that. And then bonus question, because thanks for notifying me about that. I forgot that JIPipe does this here automatically for you, and then you have your final all-in-one results automatically, and you did not need to merge table rows. I anyway had no time to explain this properly. But actually, some of you, they looked this up in the slides, and then there was good explanation. So anyway, I accepted most of the explanations there when you gave me something that looks somewhat valid. So it's just a bonus question. So task 3 is now organizing actually the pipeline. So for that, I am saving it out again. And there, thanks for notifying me that this is absolutely impossible to organize it into pre-processing and all the other compartments here with file handling. And I think many of you anyway, when you made your own pipelines, and I was very happy that most chose to go with the one that they made in task 1, you notice anyway that it has a native order it has a native way to compartmentalize. Like, okay, this makes sense to compartmentalize it that way. And when you looked at the alternative pipelines, you actually see that they are a bit more simpler, because this is actually a rule. If you're not familiar with it, it is easier to understand your own code, of course. And it also actually is easier to write code than to read code that exists. That's why the ones that I gave you are heavily annotated and explained, and they're a lot simpler as well, because then you would need to first get into my code what I gave you. And this is also a task by itself. But with that one, everyone noticed there is some kind of compartmentalization that makes sense for their pipeline. You see it even in the minimap. When you organize it neatly because you want to work on it, you actually see how these, and I saw it when I went around, like everyone organized it like that. It's just the native way. Okay, you do it channel 0, and then you do the EGFP, and then sometimes some split this up, or they put it together into one. And for this all-in-one crazy thing that I made that has all the channels, this one has actually a proper file handling compartment that keeps an eye on the files, tracks them, and then annotates them, and then this basically also its own compartment. So let's split this up because I don't have this here. We have our analysis. So you can choose to either have your existing one as a reference, and then you copy over things, or you basically move one by one from your existing one, from your existing compartment. I think I saw both strategies implemented. So let's start here with the file handling, because I have actually a proper one that does file handling. And there you have actually multiple choices. I got asked about that, so I will implement it. I just copy it out here and paste it in. And you have the choice now. You can have like one output that then you would connect all to your following paths, or then you have like a brick with a lot of unused things, because then you have the channels not used everywhere. But what you can do also in JIPipe is you can have multiple outputs. No one prevents you from having multiple outputs. And so you have a separate output for so 2 and 3 I can actually put together, because I will put them into the same compartment. And then these will yield a lot of output nodes here, but this makes it nicer to organize it later on, because you can selectively choose which data flows where. So the channel 0 file, it goes directly into channel 0. And then it's like, okay, call it C0 input file. You can choose it how you want. And then in channel 1, this is the C1 input file. Just name things always nicely, otherwise you get confused very quickly with these. And imagine you come back 3 months later and you want to read your own pipeline. Good luck with that if you organize them somehow. And then C2 input file. And then the same, we put it also into 2 and 3 here. And it's a C3 input file. So this is then our structure, and we are basically done with the file handling, organizing it nicely. Now we make different compartments, one for each our big branches. So we have the C0 TL branch. Then we have the C1 EGFP, GFP branch. And then here I decide to put 2 and 3 together. C2 and 3, this is CY3 and CY5. And then I give it only the specific ones that I disassembled earlier. If you make one output brick, then you give it basically to all 3. But then the benefit here of that is that we have only one really specific output that belongs here. Let's open them all up, then they are open. And then this way you can organize it. And then now we move stuff around. So where do we make the cutoff? And this is always very dependent on the pipeline. So where do you make a cutoff? Does it belong still into the same compartment? You decide it. It's different for each task, for each pipeline. Does it make sense to maybe put the visualizations into its own compartment? It's also dynamic. when you pipe them start out where you have like a channel in one compartment, but then at some point you have so many statistics and so many visualizations that you start shooting them off into their own compartments, or even for if you have a very complicated statistics, you have this specific statistics in one compartment only. You organize this yourself. At some point you get the feeling, okay, this is too much, too complicated for me. And then you start organization of it. Now let me move this here. And then I am copying them all out into that. So I just drag the file in, that should work immediately. And then the same for the eGFP, which is also easy to do still, because it's also just a chain of things that happen. And it goes in, stuff goes out. Should work immediately as well. And then for the 2 and 3, it's larger. So I've seen some people who chose to split this apart and then merge them later on. Absolutely fine. So I just wanted to see that you make actually use of the multiple compartments. So input file and the C3 input file. And actually now I saw this, that I forgot to copy over the final voice, because I put them somewhere down here, and then I forgot to add them. So these are the final voice. They go at the very bottom. And where is my thing? eGFP goes here. Then we have all the final voice. So this is now basically organized, at least to the point where we have the voice. And for the all-in-one visualizations and all these statistics, we need something that combines multiple things, at least. And for that, we make outputs in C0 to C2 and 3, all our compartments here. I choose here just to have one output. It's easier that way. If you think you want maybe one multiple outputs, maybe a separate one for the exported files, feel free to do that. Then they can be run independently, which is also maybe not a bad idea. Actually, let me do it, because I anyway export a lot of files, and sometimes you just don't want them out. So let's make me the export output. And there will be basically only the exporters going. So export. So we don't have to run the export necessarily when we just want to pass data along to the compartments. So these ones here, these exporters, you can hook up to the exported file that goes out of all the exporters. And then there's a little trick that you can do. I've seen some people who did this, like hooked it up. Anyway, was part of the task to do this. You can just make one, okay. You just call it exported files. You can name it anything. And then what many did is like, okay, I make another. No one prevents you from doing this. You can just hook up multiple into one, because JIPipe works with tables. And when you do such a merging operation, it just merges the table rows. This is a trivial operation that doesn't lose any information. So JIPipe will just do it. Actually, when you're trying out other languages, they will not do this for you. This is something that JIPipe exclusively does, that you can do this merging thing into one slot, because it works so much with tables. And then we have basically the task done, which asks from us, okay, please have the exported stuff out. So at least for this part here. Then we have the same thing here. We want the exported file. So they are just hooked up. We don't need to continue processing them. They are just, so they are there. And then the same for 3 and 5. There are my nodes. I move them down there. There's also, if you want to move a node to a specific location, you can right-click move a node here, and then you have like a list of the node that you can move here. And I don't need this now. And then maybe here, this one, I make a separation, like exported files CY3, and then an exported files CY5. So they are nicely separated. This one, and this one, this one. And then, for example, this is something that also some people had issues with. You can pre-add basically a slot, but this will not run because it's red here. See it? This slot is not connected to an output, but maybe you don't want to put something in yet, and you want to test your pipeline, but it doesn't let you. You can tell it, right-click, edit the slot to be optional. Then it will not complain if you don't give it anything. Then just nothing will go out in this slot. Just you have seen it that it is there. Sultan also explained it once in his pipelines, and you will see this there a lot in his output bricks that they do this. And now we have the first exports handled. And then what do we need from that? I have to think. From TL, we at least need the extended depth of focus. So this one is the TL raw, TL focused or something. And then I search the existing custom extended depth of focus. No, this one was it. Yes. And then we give it the ROI. So this one. And then here we only need the ROIs. And you can actually, when you typed in the name like that, CY3 ROIs, you can double tap enter, then it will edit. So you are faster with adding these things. And then the CY5 ROIs. And then when we, basically we have exported everything so far, and then now we do the organization for the summary statistic parts, and then the part that makes the all-in-one visualization. I have to first check if it's a good idea to do it this or that way. Not just make one like statistics and visualization. And then we grab here only the outputs because the export we actually don't need. When we open it up, we have everything to do our statistics and visualization both, if I didn't forget something, which can happen. So first our visualization, it goes in here. And I don't want to do the brick of death. I just do the one that smartly merges everything. So I give it the ROIs. And then we are done with that visualization. And then for the statistics, I just grab all of those here. And this one too. And then it goes in. So TL matches up. We have seen this all. The same thing, just reorganized. And then we see it growing a bit to the right. So maybe at some point you say, okay, maybe it's a good idea to have it as a separate compartment. This is like a decision that you then make at some point. Just be careful. Sometimes I have seen it actually that this overlap ROI, some people got maybe confused and connected it to the wrong one. Fine. I just wanted to see that you have it done. This can quickly happen, especially if you have many connections floating around. Just sometimes you have to maybe check where these things actually come, follow the colors. It's just basically an unsolvable problem. Each of these languages has these that at some point they turn into a noodle salad, and then you just don't see anything anymore. So, and then you have it organized, and then into compartments. I hope it works. Should work, I think. And it should even export everything out. So it found all my files, good. And then the alarm lists I can now delete. Don't need it anymore. And then I forgot it almost. We wanted to export out because this was, I don't know if it was requested, but then we just follow the same patterns as before. Exported files goes out. So, and then I can run that on the C project here, and then run this C project, because then I can actually run this thing a bit better. So it's currently at eGFP, I think, and then now it's in CY3, CY5. Then I can actually test it, so I don't give you a broken pipeline that doesn't work. This would be a bit inconvenient. So why is this happening? So you've noticed that, yes, we can now export everything from this compartment view. You might have to refresh it, but you have like so many of these export things floating around here, which can be then also quite inconvenient sometimes. But if you want, like, okay, I want export everything. So there are two ways. So there's the fully automated one, where I would say, run the whole project, and there you can just run the whole project at once. Go next, and then there it's a more advanced run that has a lot of settings. There you would click here this button to basically auto configure it in a way that it doesn't save any additional results, only the ones that you want. And then you click run now, and then I don't want to run it now because it starts then. And I anyway want to analyze it. And then adapt it now anyway to using project directories. I think there are some got confused with that one. What I mean with these project-wide directories is not using that one. So not using this project there, because it's like the standard input-output directory that you just get. This is where the project sits. We want to make this pipeline more useful by having the ability to select the input and output directory from the project overview, so people can just use them. And now, because I have this whole file handling setup that is more advanced, I just have only one input directory and one output directory. So I'm going to add a new directory that is in task 1, the inputs. And this is, I call it inputs. Someone's phone died. So, and then I want an output directory in task. I just make one here, task 3 output. And this is the idea that you can just put it somewhere. Maybe you will do your test audio pipeline, you maybe change it and then see if it still works. There's something interesting you can do. No one does it, not even Sultan does it. You can tell it to not check that it exists, because then it would just make one if it is not there. So let's save it before I forget it, and then it's painful. And then when we organized everything easy from the start properly like that, we can just make use of this input directory. So some people had issues finding that specific node. If you are unsure where to get like an add data node or something that produces some file or an image, You can right-click here, this Add Data. It gives you a list of everything that can be imported or be grabbed from somewhere. And what I want is, I want a folder, and I want this project user directory. Instead of my inputs folder list, I want a folder that has the key inputs, and I wrote already down that it will change and update this one here, similar to how when you drag something in. I wrote it already down, will be in the next version. Check if it works. Yes, it points to our inputs directory. And then we adapt our exporters, which is then also a bit of cumbersome task. But if you copy paste it smartly, then it's quickly done. In the edit thing here, it will capture your project directories that you have set up. So you see here a variable that this is the project data directory. This is the one that is sitting in the project overview with that key. So you can just use that instead. This is a newer feature that it makes the ones with the dot. And then we just replace the project there with that one everywhere. Many anyway have done it from the beginning like that. So they got this for free, and then they just continue to use the system all over the pipeline. So and as mentioned before, conditions need to be fulfilled. It's fine. If you forgot one, okay, I don't care. I just wanted to see that you have it done enough times, so I see that you are aware of the concept and did it. Can be anyway. There was quite of time pressure, and stuff can be forgotten when you're doing that. So no, don't worry about these things. Just want to see that you have learned it. So, and then I'm too lazy to change the output path, and it will put it in the output directory into some hierarchy, whatever. And let's. Yeah, I can show you actually. Should I do a full run? Because I don't know if it will run. Let's do a full run. Whole project customize. Next. Node-based export. So I'm trembling now. I don't know if it actually will work. So it should at some point appear here. I pray that it works. I've heard some feedback from some people, maybe not here, but from general, we have the feedback that watching these JIPipe outputs is quite calming somehow, or mesmerizing. And this is actually, all of these do something. These outputs, they have meaning. They explain how the data flows through the pipeline. Like this plus I means I'm handling now an input. It copies data over. It detects that something is not needed anymore, and then deletes it off the memory. And then I forgot to fix it. So go to the node, which that gives me the opportunity to show what happens when you have an error. Then offending node will always hit like that. You can go to it. I fixed this issue at some point. In older versions, it was not fixed. I called it everywhere dataset. I just rename it dataset in the beginning because I don't want to rename it everywhere. So, and then now we try again and then pray that it works. Node-based export, and then hope it works. In JIPipe, when it runs through things, it tries to optimize. So, because sometimes you have multiple paths that it can go, and it tries to find the path that puts the least pressure on your memory on there. There's actually a project going on where this memory issue should be solved at some point. But until then, you have to be careful with how much you load into it. But anyway, we have at least in our group machines that are for use for such very demanding image analysis tools. This includes also commercial tools, Imaris and Huygens, which they need proper hardware to do their tasks, and then they also are used for JIPipe. So now it exported the first results. So now it made all my results, including the one that is the all-in-one visualization 2. Oh, I forgot to hook it up. This is what can happen because this is an optional input. It's not fixed for my directory, but it will be when you run it on your computer, it will be fixed. So, and then we go and do some tasks here in the project overview. And then most people, whoever, when you did something that's like, even if it's like a super short description that is maybe very thin, then it's fine. I think only few people forgot to completely do it, but their points are anyway good. So it's okay. This is like a confrontation essay analysis. And then what it will make, it makes works on input that on input C stacks split by channel in folders C0, C1, C2, C3, and then like C0 is transmitted guide, C1 is EGFP spores, and C2 is CY3, and these are something, and then C3 I forgot which order, yeah, CY5, and then run the export options to save out the voice and visualizations, measurements, set the input and output there. And then you can give also additional information. You can add more authors. You can acknowledge people that maybe helped you with that, or you cite other works that maybe yours depends on. You can all do this in this overview. And then the task 3.5 was setting a license. And this is very important, actually. So there's a rule with license. There's the one that is strict. And so if you want to be strict and no one adheres to it, but if something has, this Zoom thing is broken, if something has no license, you technically can't reuse it. It is like locked, even if it's somewhere, even if it's on GitHub, even if it's on, you found it somewhere. If it has no license, you can technically not use it. They did not open it for reuse. This is why when you want to make your projects reusable, choose a license, ideally the Creative Commons with attribution 4.0, and then everyone else explained this nicely. What it does, you have to be attributed. So if someone built up their own research on yours, they have to cite you and give information. Okay, this is derived from the pipeline who was made by this person, and it allows also commercial usage. And this is not like a company takes it and uses it. The idea is that what is seen as commercial is sometimes a bit unclear. Like if, for example, you have important research that is funded maybe by a company, but it goes all public and it's open source in the end, but technically it is funded by a company and they might use it for selling it, or you have like facilities that want to sell the analysis of data using your pipeline or something, or you develop something that they're just helping people in this and to fund it. there needs to be some money transferred, and it's under some legislations this is seen as commercial, and then that it's not usable. So then that's why it's recommended to exclude the non-commercial ones. So the non-commercial ones are just a bit of a minefield. And that's why the CC-BY is the recommended one, at least from the NFDI for bioimage, which also is the one who funds JIPipe. And then I hopefully this task by myself. The pipeline is ready. And then we have a few questions. And then, okay, we have here this separation into compartments. Some people, they did a very general text about if it generally makes sense, yes. But I asked about this pipeline specifically. Does it make sense for this pipeline? Because there are some pipelines where it makes sense to separate them like that. For this pipeline, depending on how you structured it and how you build it up, I think no one ever had the idea to ever structure it like that. It's just some people tried to, and I commend the effort. Like you have like 5 million compartments and split up, but you notice yourself this is just a pipeline that doesn't fit into this standard structure. And similar to how this image, the standard steps of image analysis with its strict pre-processing, then analysis, and then post-processing, they don't ever fit. It is better for this pipeline, for example, to go by channels, C0, and then C1, and then C2 and 3, or separate them. If you have more advanced file handling, maybe move this one off into its own compartment so it's nice and separate, and you can change it easily. So it's very adaptable, and such standard structures maybe are a good start only, and not really usable for pipelines that do already something. That's what I talked already about. Why is it recommended to publish it? People can reuse it. We want to promote open science. Everyone can use it. And then many are enticed by this non-commercial ones, but this is a minefield and can prevent the pipelines to be used in environments or in projects that are actually not so. They're not like a company that wants to steal it and make money off it, but it's just like, okay, a help desk or something, but it needs funding. And then fair, that also most people answered quite well. What some people forgot a few aspects there. I was a bit more strict, and I wanted you to actually go through the fair. It's written out, okay, is my pipeline findable? No, it sits here on my computer. I have to upload it to some database online. At least to Zenodo, I have to upload it. At some point, JIPipe will get actually a better solution. It will be able to make row crates. They are like containers in a standardized format that you can upload to Workflow Hub, which the idea is like, okay, you have like a very standardized way to describe pipelines, how to describe data, how to describe the inputs and outputs. In other tools already use the standard, for example, KNIME, which is also a workflow language, or Galaxy and Nextflow, they all are already possible to be exported in this row crate standard. So look out for that. And you can also read more about these goals in this NFDI for bioimage website, because they really aim to make this data analysis also really fair and make this idea also approachable. Especially then JIPipe there is its focus to bring this into the desktop analysis to make that easy to do, and others cover other grounds like cloud computing and Python-based computing. Then accessible. So this is always a bit of what do you interpret as accessible? There are the strict definition where it's okay, you have like a database and can you access it? No, well, it's not uploaded anywhere. But accessible from a user accessibility standpoint, there it is quite accessible. You grab JIPipe and you use it. Interoperability. So this is a bit more technical or metadata related. So usually I accepted anything because this can be approached from multiple areas. So JIPipe itself can be has interoperability with many different tools, and then other tools technically can use JIPipe's own standards and make use of it as well. And reusability, of course, you have a pipeline that is saved out and can be reused by anyone. You can just open it up and then adapt it as well if you set the license correctly. So, and then this is basically it for the tasks that we went through. Do you want to know specific things that you want to see maybe some specific parts of it, or is everyone hungry and we can go home? Or I can continue go working. I have a meeting at 1. So the input. Did someone actually try this analysis at the alternative data sets? Probably not. Most people did the one that is they did themselves, but I can maybe quickly show it. You will get this whole directory from me later on, so don't worry about that. So the HiFi project, you see this? Okay, it's also somewhat, but I pre-structured it for you. This I/O interface is something that you can remember that is very nice to have. It is a interface. It behaves similar to these output nodes, but like you can make a custom one where you can just where these I/O interfaces are super nice when you have this is like a stopping point and like it's just an organizational node for you that you can use. You can you can use it to avoid bundle some stuff up that you use everywhere else, and then have like a reference point. So you can make an I/O interface and you can basically drag everything in. For example, it's like an image, and then it gets an image, and then an image goes out. It doesn't do anything, but you can use it to bundle something up, and which I also did here to bundle up these different Z projections, so I can use them later on a bit easier. So I don't have to hunt down the node above. You make use of this, so there's like a smaller way of structuring, so you don't have to make a compartment directly. This one, what does it have? It has all these standard operations as well. There, it has a Laplacian of Gaussian where you need like this one is actually interesting. So you see it once, what this Laplacian of Gaussian does. So I wanted to highlight really these dots here behind the background. And there a blob detector actually worked nicely. We couldn't, of course, try out also the top hat, but the Laplacian of Gaussian is something. It looks super weird when you look at it, but because it will make negative responses. So when you move here to the left, then you see that the value is negative because you can go in both directions. This is just its standard behavior. For example, set it to the minimum to 0, then it looks like, okay, my blobs are now enhanced. And then to do this programmatically, you can use the fast image arithmetics to basically do max 0 and then I1. It actually is very flexible. Read up about it. It has like a form. You can basically use expression style formulas in this fast image arithmetics. And you can do actually quite complex tasks very fast on our images. It's similar to how the image calculator from ImageJ works in its expression calculator, but it's very fast and you have a lot of access, including to annotations as well. You can do some interesting operations with these images. And there we have also statistics filter explicitly for the ROIs. So we don't use the fine particles to this integrated filter, because I wanted to have the median value at a specific value to filter out some parts. You can read through these pipelines in your own. They should be annotated enough, and then you have any weighted document that describes what kind of data it is. And there would be the task to organize it. Feel free to maybe do this actually, and then maybe when you have time, sit down, maybe try it out again on these other pipelines to organize them. There you have just an evil thing where you are supposed to get the condition out of the files. And there you need actually annotation processing, which I could not talk so much about, but it's actually not that hard. Here I just gave it a file, the individual files as input, and then I set the condition, which is important for this data apparently, manually with set annotation. But you can, of course, do this automatically. So let me save this maybe out as hyphy is incomplete. Batch test. If I give it the alternative 1 inputs, yes, it's just a folder. So I have your folder. I list all files inside. List files. Same thing as before. Was it CZI? I use here the TIFF one because then I get a start to change it to CZY. So only CZY. And I grab the annotation out. So annotate name. And then the data set has the annotation, but I also want the condition out of that as well. So the plus, if there's a plus or a minus in there. And there are multiple ways how you can do it. You can actually do quite advanced things like splitting up the name and then grabbing out specific parts. But I'm not going to do that, or maybe I show it a bit after that. So you've seen it once. And there's a main node for that is in, I forgot its name temporarily. It's in set edit annotations. And there you can actually do a lot of annotation processing. It's actually listed also on the slides. So don't worry if you forget it. I want the annotation condition out. And what I get in is the data set, but it doesn't show here because sometimes this thing is a bit broken. And and I can have like a simple if-else. If-else. If a plus is in the data set, so it goes through each file and checks the data set annotation that is written there. Then I give it a plus, otherwise it's a minus. How can I read about this if else, what it does, search it, and then there is a description of what it does. So it returns the second parameter if the first one is true, and otherwise it returns the third one. So accept it, and then let's see if it works. And then here it picked out that this one has a plus, this one has no plus, so it has a minus, and then so on. You can, of course, modify this, and then with the set edit annotation, for example, you can grab out for example, the first name of the file. So I add another one, it's like something, it's like species or something. I don't know if this is actually the species. You can use like split the data set apart by something. Here I split the string data set by space. And if I just run this, then you see what comes out is that it basically splits this apart into a list. So this is basically how it displays a list, like Fumi, acid, NaCl. So on this, basically this comma means it is a list. And from a list, I can take out specific things. For example, I take at 0. It's like the way how you access indices or something from a list. Only the first one starts always with 0 in programming. Then it takes here the Fumi out of the name. And from the others, it takes the Orise out of the name. And this way you can split this really apart. And then now you can imagine if you have some nice formula to grab this stuff out of your file names, and then someone decides, oh, let's make an underscore or a minus because they are the same as a space or something. Your formula breaks, and then you get weird things, and then you sit there and then curse at whoever made that, because then you have to adapt. You have to branch off. Okay, is it like one that has spaces in there, one that has underscores in there, or one that has minuses in there? And then this is why usually you end up with file handling compartments that are very large, because then they decided to change the way how you store the images or maybe reorder the information in there. And then you sit there and have to adapt to it programmatically in some way. This is a good way to basically, yes?